Then there's one more thing that we look at, okay, which is called CAP curve, cumulative accuracy profile. Okay. Now, CAP curve talks about how many minimum attempts are you taking to get it right. Okay. So I'll take example and then we'll come back to this CAP curve. Okay. So let's say there are 10,000 people in your community or in your city, let's say. Okay, total population is 10,000. Okay, now I am selling a product. Okay, out of this 10,000, let's say 7,000 people will be interested to buy. Let's say.
Well, sir, the
7,000.
first mistake that we're doing is selling it in a city which has little to no population.
No. These are $1 million ticket item.
So you're only making 70 million.
The
I mean, what? 7 billion.
7 billion. I want to make 7 billion. Yes.
Yeah, but think of it. If you do it in millions,
No.
millions, let's say you
See,
do it
the
in
thing
NYC.
is, that's the problem. Okay, you cannot start thinking that everybody is your customer. You have to start from somewhere. If you think that everybody is a customer, you'll have to spend a lot more money, okay, to identify who your customer is.
But demand and supply, right? Look, if you have the demand, if you correctly advertise it and you
The
have the
demand and
demand,
supply is there.
supply
Now
will come. Supply will come, right?
Wait. Everybody wants to learn data science. Okay. I can start my own institute. Now, do you think that if I start my own institute, I will get same number of people as the quality thought?
No.
Correct. Supply is there, demand is there, right? So it's not about demand and supply. It is about finding, even if there is only one person in the world who wants to learn data science, and if you're able to reach that one person, you make money. But even there are 100 people ready to do data science course, and if you start your institute and if you don't know how to run it, you don't know how to reach to your potential customer, will you be able to make money? No. Loss.
Yes.
Answer is, and this is what classification is going to do. This is exactly what I'm going to talk about. How to find. So I know that 70% demand is there for this product. Okay, 70% demand is there. But how do I reach that 70% people? Okay, now let's say that cost of reaching to each person is $1,000. Okay, you're getting $1 million profit sales, but there's associated cost also, 1,000 cost. Whether you call, you go, meet, you do the presentation, etc., whatever, there is 1,000 cost. Okay, now if you do not use any machine learning model, okay, so let's say this is the number of attempts you are doing, and this is the number of people. Okay, so at max you have 10,000. If you are not doing machine learning model, if you are going just randomly, you're going and meeting everybody, then what happens is you will be going and meeting 1%, 2%, 3%. Okay, you will be reaching 10,000 people at some time, right? So this is your curve, right? Because when you meet 7 out of 10, they will buy 7 out of 10, right? On average, this is what average is. 70% will buy. That means when you meet 10 people, 7 will buy. Another 10 people you meet, 7 will buy.
Yes.
Right? So 10 people, 7, 20 people, 14. So on, you meet. Okay. In fact, I should do it differently. Okay. So, okay, this is your 10,000 people actually, right? And this is only 7,000. So, you meet 7,000, right? 10 people, 7, 10, 7, 10, 7, 10, 7, right? 20, 14, 30, 21. So you will be able to cover all the 7K. You are able to sell all the 7K, right? You make $7 billion and you end up spending $1 billion, right? 1K into 10. So 10, $1 billion, whatever. Okay. The best case, you know exactly who the 7,000 people are, right? You have developed a model and 100% accuracy, there's no error at all. you are able to know exactly who the 7,000 people are, right? Then you'll be able to meet this 7,000 at 7,000 itself, isn't it? Okay, so this is your 7,000. So you will reach 7,000 directly here. Okay, this is the minimum cost possible. And you have reached.
So what you're saying is that if we don't know the 7,000, then we have to spend million 1K for
This is
each
the average
person.
case, right? That's what we meant. You know, before today, before doing machine learning, this is what we used to do, right? Randomly go and
Right.
talk to everybody on the road, talk to everybody and try to sell. Okay, then you see that every day you go, every day you talk to 20 people, 5 people will buy. That is 25% accuracy. But now
Right.
you are using machine learning, and by looking at the face only, you are able to know whether the person will buy your product or not. Best model, by looking at the face. So now you will meet only 5 people, you'll talk to only 5 people, or you'll talk to only 20 people who matches your description, and all the 20 will buy. So in the city,
No, not like that. But if I'm just trying to understand, we have, let's say, so every person we give it to, it costs us 1K, right? Now,
yes,
if our best case scenario or minimum is where our acquisition goes down and we just know everyone and everyone's buying it.
correct. But still you have to pay 1K per person, right? The talking and meeting requires 1K, right? So here you
Okay.
are spending 10K into 1K, correct?
Okay.
And here you are spending 7K into 1K.
Oh, so 10K into 1K because we would have to talk to everyone
Everybody,
and then instead.
right?
Okay.
Right? The worst
Yeah.
case. And this is the
Okay.
best case, right? So this is the best case when you know exactly who the 7,000 people are. So you are meeting and you reached your goal. But model
Right.
will be not exact best case, right? The mathematical model that we are going to use, that the one that we're going to learn, will be somewhere in between. Okay, somewhere in
Okay.
between, right? This is called cap curve. Okay,
Okay.
cap curve. The curve that you see is called cap curve. It is called as cumulative accuracy profile. Cumulative accuracy, total accuracy profile. Okay. So one more option is that you draw all the cap curve for all the model, and whichever gives you more area, right, closer to the best case, or more area, right? If you look at this one, this has only this much area. This has the entire area, right? So we say that the model which has higher cap curve is the most preferred method, like R square. This is counterpart of R square. You know, you're performing, you're measuring with respect to the average. This is the average case, bottom. Okay, your model has to be better than the average. Otherwise, why do you apply model? You can just walk out and randomly pick people. Okay, this is the best case, perfect model, where you know your potential 10,000 customers, okay, within 10,000, right? And but your model will be somewhere in between. Let's say this is gray is one model, orange is one model. Okay, so in this case, orange is the better model than gray. Higher the cap curve area, okay, better it is. So we look at specificity, sensitivity, accuracy, misclassification rate, and also look at cap curve. Okay, so this is what we say, and generally based on the cap curve, okay, if if it is less than 60%, cap area in the graph, we say rubbish model. Okay, 60 to 70 is poor, more than 80 is what considered good. Okay, so 100% is impossible. 100% means like you became god, right? So what it says is, if you're getting 90 to 100%, that means too good to be true. That means you're most probably you are in overfitting category.
Yeah.
Go
Yes,
back
sir.
and see how can I get 90% accuracy. Okay, so 70 to 90% is believable. More than 95% is unbelievable, right? I mean, how can you get so much of accuracy? Okay, so this is how we evaluate. And now tomorrow onwards, okay, we will just take one by one examples and we will solve. Okay,
Okay.
now your pre-processing exactly same. Post processing, the model evaluation is different because here we don't have numbers. So we have to look at how many correct, how many wrong you got, right? And we create confusion metrics. We look at cap curve. Okay. Now tomorrow onwards, maybe it's next 3-4 days, we will finish our classification also.
Yes.
Okay.
Yes, sir.